Hello everyone, welcome back to the verification lab. This is our fourth video on the Linux series, or we can say our last video in the Linux command, which are mostly used in design verification. So our first topic of today will be process and job control. So what is a process? A process is a running program. When you launch a simulation, opens a tool, run a script, or start a command, the operating system create a process for it. And job control means managing commands that are running in the foreground or background. This is useful when long simulation or script are running from the terminal. Now let us discuss the processes. To see the processes, we will be using command PS, which means process status. So these are all the processes. So to filter it out, we have to see which are the current ongoing process, and for that we will be using PS-E for the ongoing process and flag F for long listing formatting. So this is the ongoing processes and in the long listing formatting. And now let us understand all the column. So we have an UID, which is the user ID. PID stand for process ID. So user ID means which user has triggered this process. So it will give the user detail. PID is stand for the process ID. That means for current process, what is the ID? PPID is the parent of a current process. TTY is the terminal. We can have a multiple terminal running executing a command. So it gives us about the number of terminal, or not number, just the identify the which terminal has executed this command. S time is the starting time of the process, and command is the respective command for which the process is ongoing. So these are all the like we can say process status. So we can use different version. For example, if we use PS-EF with pipe, so it is an operator I will be discussing. We can use grep to find the process of our importance. So what we are trying to do here, we are listing all the processes, and whatever be our output, we are just selecting the output as a scene of our own convenience. So pipe symbol sends output of one command into other commands. So if I press enter, so you can see, I can see one processes which is known as from Questa scene. It is running, executing, and I can identify using the grep command. So similarly, that we want some dummy process to execute in the background. So what we have to do? We have to write a process and we have to run it in the background. So what we are doing to do? We will be using ampersand. When you give ampersand, the process will execute in the background. Yeah. So this is the ID. So basically ampersand means the command is running in the background. So now to check, so what are the all the processes that are running in the background? So we have to use a command known as jobs. So by this job, we can see this sleep 100 is being executed on the background. So we have to take it to the foreground. For this, we will be using command fg percentage and give the process ID and press the enter. So you can see now it has come to foreground and it is like consuming our terminal. So to end this, we have to use Control C. In real DB work, this helps when simulation or scripts are running in the backgrounds. Now we will be discussing one of the more important concepts, that is environment variable. So first, what is an environment variable? An environment variable is a name, value stored in the shell environment. Program and script can read these values to know the path, tool setting, project location, simulator option, and configuration values. For example, a DV project may use project home to know where the project is located, CM tool to select the simulator, or UVM verbosity to control the UVM log printing. Environment variables are important because many EDA tools and project scripts depend on them. If a required variable is missing or wrong, the compile or simulation flow may fail. So DB tool often dependent on environmental variable. So to print the path, we can use echo and use the $path. Okay, so now we will be setting environmental variable. To set that, we have to use command export, and we have to give a name. So what I am doing here, I am setting my environment as in project home, and I am giving the present working directory for this project. So let me press enter. So it has been set now. To see whether it is set properly or not, we have to use echo dollar, and we have to use project home. So you can see our present working directory is stored in the environment variable project home. Now let us do same thing for our simulator. For that we have to use export and sim tool equal to question. So we are setting our environment variable sim tool to questa sim. So yeah, it has been set. Now again we have to print that to know whether the simulation tool, whether the environmental variable has set or not. For that we will be using echo. So you can see when I press echo $sim tool, we are getting questa. So our sim tool has been selected to questa sim. To see all the environmental variable, we can use the command env. So if we press, you can see all the environmental variable. I have so many set. So you can see, yeah, this is how the environmental variable detail can be achieved. And to find where a command is located, we can use command like which dash. Yeah. In real project, variable are used for tool path, library path, project path, and simulator selection, UVM setting, and regression configuration. So this is the end of my second module. In today's session, the third module is text processing command. So first, what is a text processing? Text processing means filtering, extracting, sorting, replacing, or formatting text from a file or a command output. In DB, text processing is useful for reading CSV files, extracting coverage number, filtering logs, counting repeated transactions, and preparing quick debug summaries for a large text file. Now, let us use some of the text processing command. So let us print the coverage CSV file. For that, we will be using cat. I will go to the folder actual. Inside actual, I have a file name is coverage.csv. So if I press enter, you can see like we have 3 columns, and to extract the first column, we can use command cut -d, where -d means delimiter. What is the separating symbol for this column? So we are using comma. Then we have -f1 is the first column, and we will be giving our directory. So this is like actual and our file name. So you can see only first column has been printed. So here we have been using two flag -d, or you can say -d. -d is the delimiter, means what separates our column. So you can see comma is separating our column. So whatever we have delimiter, you can put after -d. Then we have -f1. It stands for like field number. So basically we are getting for field 1, means our column 1. So we will be using that. Now we will use one of the other command, and that is awk. So we can use awk -f. So basically here f is delimiter, or you can say field separator. Then we have to print. We have to use print $1 comma $3, and like we have to close it. Then we have to give the directory location which we have actual, and our file is like coverage.csv. So yeah, so you can see here our first and third is only printed. So by this you can selectively print columns. Now we can use sed to print the selected line. So let me show you how the sed is being used. So we'll be using sed -n. Then we have like line number. So line number 1, 2, 5 we'll be printing. Then we have our location. So our location is log and like scene, and we will be giving the file name here. So sed is useful for editing or filtering text stream. So you can see actually if you see the cat of this location, so it has too many number of files, but we are only printing from line number 1 to line number 5. So this is what seed does. Now let us see how to sort a transaction. So how to sort a transaction, we will be using keyword sort, and then we will go to our directory. Then we will be using the file in which we want sorting. So see, the all sort has been done. Now let's say you want to sort and get a number of like how many read happen, how many write happens. So how to do this? So we will be using sort command with a pipe for getting output of this to the input of our next command, and we will be using unique -c. So you can see that how many number this command has happened. So it will display those things. These commands are very useful when analyzing logs, report, transaction dumps, and coverage summaries. So this is my last module of this video. So this is a mini debug workflow. First, what is a debug workflow? A debug workflow is a step-by-step method to understand why something failed. In DB, a typical debug workflow starts from failing regression or simulation log, then searches error message, checks source references, compare expected and actual output, review coverage or reports, and finally collect useful file for sharing. Now let us do a small DB debug flow using the command we have learned. Assume our regression failed. First, let us check the log directory. For that, we will be using ls-ltr, okay, and our folder name logs, where L is for long listing, T for time, and R for recursive. So it will show a long listing sorted by time. Now inspect the failing log. For that, I will be using tail -n 20. So from below it will check 20 number of lines. Then we will give our directory and the file name. So sim fail is our file name. So you can see from below it has scanned last 20 lines. Now let us grep to find. So we'll be finding grep -n, and for line number, E for extensive grep, because we are not searching a single word, we will be searching multiple words. So what are the multiple words? Error, as well as fatal, as well as assert. Then we will use our directory logs and sim fail as our file. So we can see line number 8, line number 9, and line number 10. This has other error or have assert or have fail in them. So we can see an ALU mismatch also. Now search the ALU mismatch. If to search them, we will be using grep keyword. So we'll be searching in our article file as well as TB file. So you can see in TB file, line number 16 and line number 18, there are two ALU mismatch. So here we can see that like there is a mismatch. Now let us find the comparison command to like see actual value and expected value. So for that we'll be using command diff under -u. Then we will be giving our expected. So in the expected we have ALU expected text, and in the actual we have our ALU actual. So yeah, so we have an expected and actual, and this is the how difference give us an idea where the change has happened. So to analyze this, so we can see there are two files. First file is denoted by minus minus minus. Second file is like plus plus plus. So in the third line you can see minus. So it is representing and the first file expected. So from line number 1 to 5 it is taking. Similarly for second file it is taking from line number 1 to line number 5. And you can see there is only one change in the second and the third. There is one minus and then is one plus. So if you see operation is sub, A is stand for the both, B is 4, but in case of Y, one is 00C and one is 10C. So this is how the difference help us to find the difference between two text, or you can say two files. So you can see here our sub operation. Our sub operation have a mismatch. Now let us check the coverage. For that I am using our command cat. I'll go to my HCL and then coverage.csv to see the content of the file. So now let's say we want to print only the percentage. What is the percentage of like our block coverage? So for that we will be using awk off command with a delimiter as -f. Then I will give my delimiter which is comma. Then I will give dollar, and before that we have to use print and $1, so that our first column got printed. Then we want only our third column. So for that $3, then I have to close it and give the location. So it is under actual directory and the file name is coverage.csv. So you can see like only our first block and percentage. So these two columns were printed by this. Finally, we will be collecting all the data. Okay, and like we will be minimizing the size. So for that we will be using tar as we have seen earlier, and we will be using like our flag as CZVF, and we will give like debug bundle.gh file. We have logs, expected, actual, and reports. Yeah, so this create one compressed file that you can share with our teammate or attach to debug ticket. So now I move to the conclusion of this lecture. So in this video we have learned Linux command for design verification point of view. From the first video to the last video, we have covered navigation, file management, viewing logs, searching with grep, finding files, comparing expected and actual results, permission, disk usage, archives, processes, environmental variables, and text processing. The main point in this, Linux commands helps DB engineer debug faster. When a simulation fails, you should be comfortable moving through the folder, opening logs, searching error, comparing files, checking reports, and collecting debug data. If you are starting your DB journey, practice this command regularly. Open a terminal, run them on a dummy files, and slowly build speed. This is all for this video. Thank you for watching. You can like, share and subscribe. Thank you guys.